Good afternoon. Welcome to the EFG webinar, Multiple Target Horizon Exploration for the Implementation of an Integrated Geothermal System for Göttingen, Germany. My name is János Szanyi. I am the coordinator of the panel of experts on geothermal energy of the European Federation of Geologists. I will be the host of today's webinar. So the European Federation of Geologists is periodically organizing webinars to foster the professional development of fellow geologists and to increase public awareness of the importance of geoscience. I'm happy to present the speaker of today's webinars, Dr. Bernd Leiss. Bernd Leiss is a structural geologist with an originally strong background in the analysis of the formation mechanism based on quantitative microfabric analysis. Within the last 15 years, he focused on the field-based development and integration of different innovative geothermal systems. Based at the University of Göttingen, his research activities brought him, for example, for fieldwork in Namibia, to the Joint Institute for Nuclear Research in Dubna in Russia, the University of Berkeley, California, and the Hong Kong University of Science and Technology. His teaching activities include the geosystem-based energy sources within the bachelor course Ecosystem Management. Before giving the floor to our speaker today, I wanted to remind you that after the presentation, there will be question and answer sessions. We invite you all to propose questions to the presenters through the YouTube chat, in the chat window, and we will select and answer some of these questions at the end of the webinar. So, and without further delay, Bernd, please, you can start if you are ready.
Yes, thank you. I'm ready. So, many thanks for inviting me, and many thanks for the nice introduction. So I start joining my presentation. I think you can see it now. Well, the title sounds very specific on a study case in Göttingen in Germany. But of course, this is not only focused on Göttingen. This presentation is meant in the framework of the big objective. It means heat energy transition in Europe. Göttingen, in this case, it's just a demonstration site with a special approach, which I will introduce today. And in this context, I can show you some results of the completed EU-HORIZON2020 project MEET, which supported the investigation in Göttingen a lot within the last years. I will talk about enhanced and integrated geothermal systems, specifically focusing on Göttingen. And of course, the most important thing is the strategies to overcome barriers with regard to the implementation, because we all know geothermal energy has a high potential for the heat energy transition, but still we have to boost this in a strong way. So if we look at Europe, and we want at the end, of course, to boost the geothermal energy, the use of geothermal energy in Europe to a much larger extent. So we do not want, or we cannot only look to the places where we have very good geological conditions. We have to extend to new regions. We have to explore new geothermal plays, and we have to develop enhanced geothermal systems and also to implement them. If we look at this map, we can see the potential or the rocks of the Variscan basement, the crystalline basement rocks, and the Variscan metasediment. So in red-orange, we have the granitic rocks and the granitoids. And in the gray color, starting here, you see also the location of Göttingen in the gray color. It's these foreland belts striking to the Ardennes Mountains. and to southwest England up to Ireland. And and for all this area, we want to develop these enhanced geothermal systems. And you see, if we look at, I'm speaking now on deep geothermal energy, this is a large area which has to be developed. As mentioned already, it was the MEET project with which we focused on the development of the deep geothermal energy. So MEET comes from multidisciplinary and multi-context demonstration of EGS exploration and exploitation techniques and potentials, also a long title. And the project ran from May 2018 to October 2022. So it was just finished. This is also a big graph, but I just want to give you a quick overview on the MEET project on this EGS development. So one focus was also on the transition of oil wells to geothermal wells. But our Göttingen project is located in this red box, which is focusing on directly on the Variscan basement. And we have several projects. And here we have the technology readiness level. And you see we all had strategies, started at different readiness levels and brought projects to higher levels. So we started with just basic concepts up to improving running projects like in Sul-Forêt by improving the energy extraction by lowering, for example, the temperature of the re-injected fluid. We want now to focus on Göttingen. And before I do that, I want to announce that a lot of the results of this MEET project were just published in this special issue of Geosciences. It's open access, and you find the link here below. So everyone who is interested is welcome to download this issue. Yeah, then let's go to this Variscan basement. The approach was like this. We focused at 2 demonstration sites on granitic rocks. This is the lower case, and on 2 locations on these Variscan metasediments. On the left side, these 2 demonstration sites, looking at the geology, they were overprinted by extensional tectonics, which we always assume is an advantage in view of capabilities. Then we have further differentiation. For example, as already said, Sul-Forêt in the Rheingraben Valley, it already has a running power plant, and we had have a running geothermal system, an enhanced geothermal system with hydraulic stimulation in granitic rocks. Then we have the demonstration site in Cornwall, where a doublet was drilled during the MEET time, and then also chemical stimulations were done for improving the wall of the well. And we have in Avalanche on the upper right, we have a well of 5,000 meter depth, but it is an old oil well for exploration. But we have a well in such metasediments, but we have still no infrastructure there. And then we go to Göttingen, where we have a very well suited infrastructure, especially the campus of the University of Göttingen, but we don't have a well. We didn't have seismic measurements and so on. So it's a very underdeveloped play. So, but it's driven by the high demand of energy by the city and the campus of the University of Göttingen. Just to let you know, yeah, in Germany, and Göttingen is more or less located in the center of Germany. And on the right hand, you see the old town here in the center and the area of the university campus, on which I will focus now in the first step. And this campus, the heat supply for the campus comes from this combined heat and power plant you see here on the left side. And we have a district heating system distributing the heat. Yes, and the power plant is gas-based combined heat and power generation. And it's based on gas. And just to give you an idea on the size of the district heating system, it's about 13 kilometers heating pipe supplying 250 building units. And we have a consumption of 20 to 25% of the natural gas consumption of Göttingen in total. So if we look, and this is now focusing on the campus, we have a we have a need of thermal energy during the year. See the annual load curve of effective energy. So we have these scenarios. What kind of power plant or what would be the power we need for a geothermal plant? If we have 20 megawatt, we could cover around 70%. If we have 30 megawatt, we could cover around 85%. So this is the size we are aiming for. And as you know, in such undeveloped rocks like Variscan metasediments, that's quite a challenge. Just to let you know, we have an output of 100,000 CO2 tons per year, and running costs about, the gas costs about 7 million euros per year before the Ukrainian war. So these are the boundary conditions from the consumption side. And of course, the vision would be that we have a geothermal power plant as in Rittershofen in the Alsace, close to Sul-sur-Forêt, where we have a 24 megawatt heat production. So that would be nice to have, but of course, the geological conditions are different in Göttingen, not like in the Upper Rhine-Graben. So the Göttingen University campus has a many-faceted existing surface and cooling delivering infrastructure. Cooling is an important point in the energy production. And we also have old building stock, and also new buildings are planned, e.g. the medical center. And of course, the old buildings need a redevelopment. So that's quite good infrastructure, but how is the geological setting? Can we develop energy for such a demand? Geologically, Göttingen is situated within the Leinetal-Graben structure. So this is within Triassic unit. So we have a sedimentary cover on top of these Variscan rocks. And as said before, we have an extensional tectonic regime, no activity anymore. If we look at a very simple cross-section, east-west cross-section through a structure, we just know from surface mapping, there are only a very few wells. You can see them, these 4 wells in the right scale. So we just got with one well, touched the Variscan basement. All other wells are only up to 1,000 meters. And we have not much information on the Variscan basement here. And also, of course, the structure of the Leinethal is, there are a lot of questions because we don't have any wells. So we have the Mesozoic sediments here, and below that we have the Permian Zechstein salinar, means salt and potash salts. These three layers give us the chance to develop different geothermal systems. Means deep geothermal systems in the Variscan basement, medium deep geothermal systems focusing on these Zechstein salinar, and of course shallow to medium deep systems in the Mesozoic cover. So we have a relative complex geology, but on the other hand, this gives us the chance to develop geothermal energy systems in different layers, in different targets. So what is the pre-drilling exploration at Göttingen? So we still have no well. We are just hopefully just before a decision if a well will be drilled. So what have we done before as the pre-drilling measures? In 2015, we ran a seismic campaign. And just as additional information, in Göttingen in 1890-80, first Institute of Geophysics was founded by Emil Wiechert. Emil Wiechert is famous because he developed these seismographs, which are still running in Göttingen and which are still preserved for the future. And also Mintrop, who learned with Wiechert, he developed a seismic analysis by developing or using a 4-ton weight, which you can let fall down from a tower, and you can produce these seismic waves and analyze them. Then Mintrop went to the US and made a big business from that. And in Göttingen, unfortunately, we don't have a geophysics institute anymore, but we came back in 2015 with the modern equipment to Göttingen and did this seismic campaign, which was looking at the point that we did this through the city, was quite successful. So we had no problems and people were very interested and asking when can they get heat from geothermal energy. So we run 2 seismic lines to get a pseudo 3D idea from the underground. Of course, the cross is just around this northern campus, so we get most information on a possible location. This is the old town here. And yeah, we started to model the underground, and we can see the structures in the Permo-Mesozoic cover, but of course in the Variscan rocks without having a research well to indicate different lithologies and structures. Not much is possible, but for the medium deep geothermal energy, this is very fine. And we start now to find locations for research well, which should be also used for energy production. This is now done by the municipal energy supplier, not by the university itself. So we indicated 3 target horizons in the carbonates, in the sandstones, and also in the rock salt, and where we also find dolomites and so on. So here we have 3 targets for medium deep geothermal energy. This is, as I said, just under evaluation, and our target or our objective for first research well is for these targets in 1,500 to 2,000 meters maximum. We hope that we can add a few meters to get also in the Variscan metasediments. Now we come back to the MEET project, where we focus on the deep geothermal energy, and you can see that Göttingen is just between the Harz Mountains. As this is where the Variscan rocks are exposed in Germany, and they are also exposed in the Rhenish Massif and also in the Ardennes Mountains, where this other location, Avalanche, is where this 5,000 meter well is located. So from correlating structures from the Harz Mountains to the Rhenish Massif, we can assume that below Göttingen, we have similar rocks like they are exposed in the Western Harz Mountains. That's why we focused our analog studies to the Western Harz Mountains. And the basic idea was to study the structures, the folds and thrusts, and to develop a real 3D structural model. So the general approach is shown here. This is a fold and thrust structure from another paper, not from the Harz Mountains, but our basic idea was that we make 3D field surveys from outcrops and from also research wells in the Harz Mountains. There's also a little bit seismic. There's a lot of mining. From all this information, we make a structural model. Then we reduce the information to a conceptual structural model. We measured in the lab the petrophysical parameters, so we can make a parametrization of the different lithologies, and then we can make a reservoir model. Of course, the lithologies are important. In the Western Harz Mountains, they are dominated by slates and greywackes. So we focused also on these 2 rocks. And the other question is, of course, at what places, at what locations in the structures, which locations are best suited for developing a geothermal system? This sketch shows that quite nicely, where we have the highest anisotropy, where we have the highest joint system, or the highest density of joints. So where we can expect most of the permeability. So this was also the parametrization was intended to be combined with these field surveys. Also in connection with the 3D field surveys with photogrammetry and laser scanning, hoping that one can detect say in general the fracture densities. So we have a lot of joint systems, and we have also veins showing us paleo stress, and also paleo fracture systems. All right. In the course of this investigation, so when we discussed this with the reservoir modelers, we were aware that this was not an expedient way in this case. Because, of course, the reservoir modelers, they need a developed reservoir. That means you have to know what is the density of fractures, of joints, for example, of cleavages. What is the aperture of these fractures? This is, of course, cannot say, because you can say this in the exposure, but not in 4,000 meter depth. For us, the question is which of these pre-existing fractures we can stimulate. Because, of course, we need to develop enhanced geothermal systems. It means that we have to open these fractures. So we need to know how far we have to open them, what kind of aperture we have to develop. So this approach is also not for predicting the flow rates, and that means also not for the calculating of the productivity at the end. So we did a change of the approach, and we started with more diagram modeling. So that means, what are the conditions we need for stimulation measures? It means thermal and hydraulic stimulations, that we can develop fractures for permeability. Because one of the big questions, of course, was also, is it possible to develop fractures in the slates? And what kind of planar elements would open? Would it be the cleavage or possible joint sets? And that's quite difficult to say, because in the lab, if we run lab investigations, we use intact rocks and to investigate the anisotropy and to get the boundary conditions for large volumes. That means in reservoir size, that's quite different. So we simplified this approach to this more diagram modeling. And this is published for those who are more interested. You can find most or nearly all of our publications as open access. In addition to that, what I just touched is also a look at these analog exposure studies. An evaluation on that you can also find in another manuscript, where we list where we recommend what makes sense on these analog exposure studies, what lessons we have learned. One I told you already. So especially looking when we select rock exposures and when we select rocks for lab investigations and so on. And the next step, what we changed, is also quite crucial in all these things when we then work together with the economic analysts, because they are always asking, similar to the reservoir modelers, what are the conditions in 4,000 meters depth, and how much water you can produce in what time? And of course, in an undeveloped reservoir, we cannot answer that. So we turned it around and said, what would be the minimum requirements from geothermal energy to be economic? And this was done with scenario analysis. And one scenario is, for example, if we get subsidies for well and combine it with research funding, the minimum requirement would be 8 megawatt It means 30 liters per second and 125 degrees. This is still quite challenging, but these numbers are also before the Ukrainian war. This is now, of course, changed. And what else? And this is also one of the an important point one has to consider here, that it's only focusing if we don't change the heat demand, if we keep it on the same level. Because in with this scenario, we could cover around 20% of the heat demand. But if we have less heat demand, the portion of geothermal energy would rise, and then the economic scenario would be completely different. So that means that we need also a plan how the energy demand is in the future. I come back to this later, to this point. So now you have an idea that we have these different target horizons and activities we are doing for the deep geothermal systems. And of course, the first approach was to develop an open system, as you can see here. But most of you will know that also deep geothermal systems, that also closed loop systems are now under development. One system is, for example, the EVER system, which is quite famous because it's promoted very well. And that could be another option. So all the data we produced from our modeling, maybe I forgot to tell you that this model on the upper side, the structural model, this is one of these structural models we produced from the Harz Mountains. You see the size, this is 1 kilometer. So this is really reservoir sized. What's still missing in this system are the thrusts, because they are difficult to detect in the field and then to implement them. But this is on the way. So all these structural models would be also very helpful for closed loop systems, because then we also have to know, is it better to place them along the strike of the folds or normal to it, and so on. And of course, also the rock physical properties. So that's for the deep geothermal systems. But we focused also on shallow and medium deep. So for a shallow geothermal system, we made an approach on how much energy we could technically cover in district of Göttingen and the city of Göttingen. And this was just an approach from looking on the heat demand and on the properties, how much space would be for shallow heat exchanger systems in combination, of course, with heat pumps. And we could cover 80% technically, of course, but that's quite a big amount. So here you can see the energy demand of the district Göttingen and the city. And the city of Göttingen itself needs nearly half of it. This was already done a few years ago, but still in all this debate on heat pumps installing, using also geothermal heat exchanger systems, there's still this is still not a routine application. And then if we look at the medium deep geothermal systems, where we have the salt layers below Göttingen, so there we are lucky that a few kilometers outside of Göttingen, we have an old historical salt mine. The salt is in around 800 meters depth, and you can see all these galleries here. And already many years ago, in 2008, we had a study to use this as a heat exchanger system. The biggest problem here is that the mine is closed and that we have no direct access to these galleries anymore. And that where the mine is located, we have, up to now, we have no consumer infrastructure. But this is now under a change, and there's a concept now for to use this, and especially to store energy, heat energy in the summer. So if we combine all these things, we get a real a good combination of different systems in all kinds of depth. And this, of course, could be connected to the surface infrastructure. So we have a lot of opportunity, a lot of chances and a lot of possibilities, but still we are in this exploration stage. We summarized this idea that we have many sources for geothermal energy, different depths or with different systems, with the idea also to trigger changes in the surface in the surface infrastructure. So, but of course we have to adapt the systems together, otherwise it doesn't work. If we just say we can provide this, but we don't adapt the surface buildings, then it will not work. So therefore we suggested an energy hub where we combine all kinds of renewables and think in that sense that we converge these two systems, underground and surface. And from this comes the question, what are the barriers? Why doesn't it work? Why is it still a long way to such an energy hub? And there I want to present a sketch in a minute. Just another idea, for example, this medical center here, it will be rebuilt in the next 10 years. It will be completely rebuilt. And this gives the chance also to make the new buildings fit for medium deep geothermal energy, for example, also for shallow. But then you have to develop a low temperature heat system. And of course, such a new medical center needs a lot of cooling because it produces a lot of heat by all these electrical instruments and so on. So that would be quite good also in combination with industrial heat pumps. But why is it still a long way to that? What are the barriers? If we look now on these two systems, on the surface and in the subsurface. And then we put on the surface the different units, single buildings, district, and the campus, cities, metropole regions. So it's getting more and more complex in that direction. And in the subsurface, it's getting more and more complex from shallow, medium, deep, deep. On the surface, we add also biomass, solar, wind, and other renewables. So on this, here we get a higher complexity in the two different directions. And the degree of decoupling of the systems is increasing because to bring together deep geothermal energy and the metropole region is much more complicated than just to make an optimized system with a single building and the shallow geothermal energy. So that's getting more and more complex. But what we need to bring this together, we need to construct a vision in 2030, 45, 50, whatever goal is at different locations. And we have to converge or to couple these different systems in these different sizes to reduce the energy consumption at the end at all, and to make this transformation. So that means that this conversion, which is underground mainly at the moment driven by science, or on the surface is driven by science and the society itself, especially now within the last 1 year. So this is where we have to go in the future. But if we just work in the system on the surface and just work on the system in the subsurface and expect from each other that they change the building infrastructure and they expect, they will find something, this will not work. We have to think these both systems together. So in my idea, we need this vision where we are at that time, and then think from there how we can get these different systems together. And then is the question with this coupling from our view, from geoscience, we need to learn a lot on the surface to be able to integrate it here. But the other direction is that usually it's very often very complicated. Communication is different for the decision makers here on the surface. So where are these barriers? Are they here in this communication? Are they here? Are they in the planning strategies on the surface? Wherever is this the barrier that we think only in small steps, small developing steps? Would that be a good idea to make it first this vision how district energy supplying could look like, and then we go into these directions? So that's the point which I want to stress here. So finally, to summarize that, what is needed for the implementation of a geothermal-based energy hub? So we must integrate multiple reservoirs with a multifaceted surface infrastructure to develop a long-term sustainable action plan that finally converges to a coupled system with a high efficiency. Then a big problem is the unity of purpose is needed between many players, even on a campus structure, which looks like as a very well suitable system, but still there are many different players with different interests. Then, of course, we have high uncertainties, and they need to be compensated by fallback options to develop a resilience, and not only to convince investors, but also to avoid dead ends and to have a low energy demanding system at the end. Because the dead ends, we can never be sure that one of these layers we can develop on one of these targets. So we always need backup options, which we have with these multi-targeted systems. And then while geoscientists force decisions about the subsurface, decisions about energy policy and surface infrastructure are driven by politicians. But there is also, I think, still a big communication need. And just on the last EGU in Vienna in this spring, there was a great debate on the question, the science activists, should science get political? And I mean, the European Federation, they are politically active. So that's also a big question, how scientists should act and to bring more information in these surface infrastructures. Yes, that was the summary, and of course, all these findings were also done with all these colleagues listed here, which I highly appreciate because we worked many years together. And at the end, we have again this vision coming from the rocks in the Harz Mountains to a possible geothermal power plant like in Bittershofen, for which we need as next step in Göttingen a research well. So many thanks for your interest, and yeah, I'm open for questions.
So, Bernd, thanks for our interesting presentation, especially that you spoke about the district heating purposes of geothermal energy utilization. So while we are waiting to the questions, because I'd like to say again that we invite you to submit questions through the YouTube chat. So the question what I want to ask, what are the next specific steps in Göttingen and on what time scale?
Yeah, as quickly mentioned, the next step is a research well, which we directly plan now, but we have on other places like what I showed on the salt mine. We are looking for further funding and to develop a system here. And then also on the campus, the idea is that we have other sub districts in development. So, but the breakthrough with this well, but you know, even if we get a decision this year, it takes 1 or 2 years to realize that. And then, but that would boost the development here. And the idea is that this triggers all the other systems at the other locations.
Okay, and I need to say I'm a modeler, so I have a question regarding the modeling, what you mentioned. So can you explain in more detail why reservoir modeling was not appropriate at this pre-drilling stage?
Yeah, I mentioned that quickly in the talk that you have a very high information density on these different fracture systems, let's say like this. And then it's a problem of computational power that you need for this modeling. Then we still do not know what is the aperture at the end. So that's why I said we have to change the thinking. We have to say how far we have to open these fractures. So this is a step before the georeservoir modeling. Because you can do this georeservoir modeling only when it's existing. Yeah? And of course, then also if we like to model the stimulation with finite element modeling, for example, the system is just too complex at the moment. Even the analysis in the field. So if we, for example, we take a surface, the surface conditions, the joints, the aperture of the joints, the length, and so on. Even this is still extremely variable, and we can do that in an outcrop. But if you look on a whole reservoir, it's getting more and more complex, and I think this is strongly under development. I think, or I assume that if we, for this 3D field survey analysis, as soon as we can apply artificial intelligence for then we might get a step forward. But at the moment, it's just not representative.
Yeah, I agree. But okay, during modeling, we can define with different scenarios the target range, what we need to achieve in different parameters during, for example, stimulation. So, but yeah, I understand what you said. I'm looking for the questions. I haven't seen from the audience. So I have a question regarding the Göttingen project. How could you manage to get the public acceptance in the city? Because I see a lot of vibrators and probably during drilling phase, a lot of noise we'll have. So how could you manage that?
From the very beginning, we always said it has to be transparent. So also when we started the seismic campaign, we informed the public, we invited them to join the campaign. And so this was very successful. And I think one important point was that we did it from the university. So as a local actor, it was not that an investor comes from outside and says, yeah, now we develop such a project, and people get afraid because, of course, it's the interest of the university that buildings are not falling apart and so on. I think this is so an important part in that, and people came up and asked if they can get geothermal energy. So at the moment, I think we are here in a good situation, and we want to keep this public information. That's a crucial part on it.
So thank you. And we have the first question from George Aponte. The question is, I remember something about that the flux was not easy to predict. How to assure profits if that is not possible?
Yeah, that's that's the idea, that we ask, that we look for these, in the first step, for these minimum requirements. If we can assure that, then we are a step forward. But of course, more problematic thing is the risk, if we can really achieve these permeabilities at the end. I mean, that's geothermal, the general risk.
Yeah, so as far as I know, in Germany, there is a risk mitigation fund, am I right? Or not?
Yes,
for drilling.
Yes, there's now a lot of activity going on to support the geothermal exploration now.
Okay. Check, but I haven't seen other questions. So you mentioned in your presentation the question was, should geologists become politicians or not? Or so what do you think about that? We need to in my opinion, we need to find the channels to the politicians. We not need to be make a political activity. I mean the scientists, but what do you think about that?
Well, this is that's one. Or let's start with the result from this great debate at the EGU. That was clearly said, yes, the scientists have to get active, not that they get not that they are at the end politicians, but that they get active. And of course, I think geologists are not well represented in the politics. So all these thinking we have as geoscientists concerning risks and these different approaches in this, especially in this complex thinking of systems, that should be more transported in public reception.
And in my opinion, we need to taking the wind out of the sails of populism. Sometimes it's another problem comes from politicians. They sometimes looking for the simple solutions, which sometimes is not available, and we need to highlight that it's not so easy to solve the problem in geothermal energy, like they said. Okay,
I mean, also other technologies are not so simple. If we look at green hydrogen, that's also not simple. It seems to be simple, but all the other facts which are in the background, also the efficiency, if it makes sense at all, this debate is often not in the public. Yes.
Yeah. So the geothermal systems are not so simple like photovoltaic to press the button and start to operate. So it always needs to handle some problems, corrosion and others. So yeah, it's more complex than sometimes photovoltaic and wind, for example. Okay, we have no more questions. So Bernd, many thanks for presenting in the webinar. And thank you all the participants here joining us, and it was great to you with us, and take care and see you in our upcoming webinars. Thank you very much. Have a good night.
Thank you again for invitation.
Thank you.